Hey guys, welcome to the notes for dividing polynomials, where we'll talk about the factor and reduce method. So previously in the past, I have taught this using long division. Now long division can be a lengthy process, so to make it a lot easier, we can do a process called factor and reducing. So our essential question is, how can we use previously learned information and apply it to new situations? So again, I am not going to use this video to teach long division with dividing polynomials, so I am going to skip this top section. So I'm going to just show you kind of how to do it with just the factor and reduce method, and I'll also show you how to check your answer as well. Okay, so using the knowledge we know about factoring trinomials and factor by grouping, we're going to be able to apply that here as well. So using that information that we've learned previously and applying it here. So here we have x squared plus 4x minus 5 divided by x plus 5. Now, just to remind you that in math, instead of writing like 3 divided by 4, you can also write this as 3 over 4. It means the same exact thing. So I'm going to go ahead and rewrite this in a fraction bar. So we're going to have x squared plus 4x minus 5 divided by x plus 5. Right, so the front part, or the first polynomial here, is going to go in the numerator, or top of the fraction, and then the second expression goes at the bottom of our fraction. So we're going to do a thing called factor and reduce. So we're going to factor first. Now obviously we're going to factor the top section first, and why do I say obviously? Well, if I look at x plus 5, there isn't much I can factor there. There's no GCF, there's not really much going on, so I'm not going to factor anything there. Now I'm going to go ahead and factor that top section. So we're going to factor this. Okay, so let's go ahead and factor that. Okay, so I'm going to go ahead and do that. It said queso, like cheese. Okay, so we have x squared plus 4x minus 5. We're going to factor this. Now remember, with factoring, we want to factor by grouping. Now in order to factor by grouping, we want 4 terms. Obviously, we have a trinomial here, which is 3 terms. But I teach you guys a method called the AC method, and the AC method allows us to take a trinomial and turn it into 4 terms. So it's not impossible to factor by grouping, it's just you have to create a situation where you can factor by grouping. So the first thing you always check for is you make sure it's in standard form. It is in standard form. Remember, standard form means that you're starting with the highest exponent first, and then it's decreasing. And then you check for a greatest common factor. Well, between these 3 terms, x squared, 4x, and negative 5, there is not a greatest common factor other than the number 1. Remember, 1 doesn't change anything, so we just move on and continue. So let's go ahead and identify our a, b, and c here. So our a here is going to be positive 1, our b here is positive 4, and our c here is negative 5. And we're going to use the AC method, so I want to draw my x, AC on top, b on the bottom. All right, so go ahead and multiply, right? AC is going to be a times c, which is negative 5. 1 times negative 5 is negative 5. And our b is going to be positive 4. Okay, so I need 2 numbers that multiply to negative 5 but add to positive 4. So that's when I go ahead and I list my factors. So I'm like, okay, what are factors of negative 5? Well, negative 1 times positive 5, 1 times negative 5, and that's it. Those are the only 2 factor sets that make positive or negative 5. So only one of those is going to add up to negative 4 or positive 4, and that's going to be this first one. Wow, that's really hard to see. So I'm going to go ahead and highlight it in blue. So that's going to be our special numbers. So negative 1 and positive 5. Now remember, the order doesn't matter. So if you want to do positive 5 and negative 1, that also works. But just make sure it adds up to positive 4. All right, so remember, with factoring, your first term is going to stay exactly the same. Or with the AC method, your first term stays exactly the same, and the negative 5 stays exactly the same. What you're doing here is you're uncombining the like terms. You're making the 3-term expression to become a 4-term expression. So the first term here we're going to replace with the 4x. It's going to be negative 1x and then positive 5x. Now where did I get those numbers? Again, those are our magic numbers over here. We did not get them from anywhere. And just to prove to you, remember, negative 1 and positive 5 does make positive 4, so we haven't changed anything here. We're just uncombining the like terms that were there. Now moving on to the next step, we want to factor by grouping. So because you have 4 terms, you can factor by grouping. So I'm going to split it into 2 groups. Okay, so in the first group, my GCF of this first group is positive x, just 1x. Can't take out any numbers. And then we simplify. Well, x squared divided by x is going to leave me with x. And then negative 1x divided by x leaves me with negative 1 because those x's cancel. Then I move on to the second group. I have 5x and negative 5. The largest thing I can take out of both is positive 5. No x's because that last term does not have an x. Also, I would only take out a positive 5 because the first term here is positive. So it would be positive 5, so I want to put a plus 5 there. 5 divided by 5 is 1, so we have 1x. Negative 5 divided by 5 is negative 1. And yes, I do need to write the 1 there because it is important. The next step here is you check to make sure your parentheses match each other, and they do. We both have x minus 1 in both, so we are doing this correctly. The last step here is to create your factors. So in the first factor, you're going to have your GCFs to go together. So x plus 5 is our first factor. And then our second factor here is the matching set of parentheses, so x minus 1. Now, typically, if I asked you to factor, you'd be finished. This would be your answer. You'd be all done, right? But this is dividing polynomials. So what have we done? We've just factored x squared plus 4x minus 5. We just factored this guy, right? So hopefully that you would agree that, let me go ahead and highlight. Let's do gray. That this expression and this expression are exactly the same. And actually, if I graph them, I can show you that they're exactly the same. So let me show you x squared. Let me go ahead and turn projector mode on. X squared plus 4x minus 5. And then we have x, what was our first one? X plus 5, and then x minus 1. Notice I click back and forth between both. They're the exact same graph, so they are equivalent to each other. There is no difference. It's just the way that we write it. The only difference is that we undistributed. We basically undid the double distribution to end up back where we are here. Okay, well, that's not our final answer, though, because I'm trying to divide here. So I just proved that this and this are the exact same thing. So let me go ahead and rewrite this, because this is the same thing as this, right? We just proved that. So let's go ahead and rewrite this fraction. So we have x squared, we have x plus 5, x minus 1 in the top now, in the numerator, divided by x plus 5. Okay, so this is our final step. You're dividing here. Well, it's called factor and reduce. We just factored, now we reduce. Reduce means you cancel out what they have in common. So if this is my fraction, what do we cancel out here? Well, the x plus 5s cancel each other out, which means we're left with x minus 1. And that is our answer. So what is dividing polynomials really doing? So they're basically being like, hey, divide this. I'm giving you one of the factors. I want you to find the other one. So notice when we factor this, see how x plus 5 is one of our factors? They're saying, hey, this is one of the factors. I want you to find the other one. And we found the other one, which is going to be x minus 1. So that's going to be our answer there. So really, after the factoring, all you have to do is reduce. Now, how do you check this? Well, you can check this by seeing, does x minus 1 times x plus 5 make x squared plus 4x minus 5? So let's go ahead and check that. So we have x plus 5, x minus 1. Let's check this over here. I will use this pink color. I don't think I've used it yet. Oh, I have. I haven't used purple, though, yet, so I'll use purple. Okay, let's check this. So we have x times x, which is x squared, x times negative 1, which is negative 1x, 5 times x is 5x, 5 times negative 1 is negative 5. Next step here is you could combine like terms, so negative 1x and positive 5x would combine together, and that would make x squared plus 4x minus 5. Is that what we end up with at the beginning? Yes, it is, so this is correct. So really with factor and reduce, you factor and then you reduce. So the only extra step is this step right here. So all of this is the same as the previous days. The only extra step is, again, that very end step where you're going to reduce it. All right, just another example. This is a random example, so obviously it's nothing to do with what we have going on here. Right? After you factor, let's say you end up with this at the top, you would reduce, right? So you would cross out what they have in common. So these would cancel out, and all you would have left is 2x minus 5, and that would be your answer. So that's kind of what we're doing here. So that last step is the reduce step, and that's what we would end up having to do. All right, let's go ahead and do number 2. Again, these notes were set up originally for me to do long division and factor and reduce, which is why it's split up in 2 sides. But we're going to go ahead and just do the factor and reduce method here. So let's go ahead and set this up in fraction form. So we have 7m squared minus 60m plus 32 all over m minus 8. All right, so first step is factor. We're going to factor that trinomial in the top. So we have 7m squared minus 60m plus 32, and I want to factor this guy out. So let's go ahead and identify our A, B, and C here. So A is, before I do that, I check for GCF. I'm so sorry. It is in standard form. There is not a GCF. There's not a number or a variable that can go into either or any of those terms in either 3 terms. Either? I feel like either's only 2, but it's fine. Okay, so let's identify A, B, and C. 7 is our A. Our B is negative 60, and our C is positive 32. It looks like we have some very large numbers here, so this one is going to be one where we're going to have to think about the numbers a little bit. Or we can use that calculator trick. Again, if you don't know the calculator trick to find factors really easily, you can go ahead and come see me and I can show you how to do that trick. So AC is going to be A times C, which is 7 times 32, and that's a huge number, 7 times 32. That is 224. And our denominator, or not our denominator, our bottom number is going to be negative 60. So I want these two numbers to add to negative 60 but multiply to 224. So I guess I better start dividing out, right? Let's start dividing numbers. 224, so here we go. I'm actually going to make this blue, which means I'm probably going to make these up here blue as well, just to make everything consistent, because I'm kind of like that. All right. 224. All right, so let's obviously, we want numbers to add up to negative 60. So 224 divided by 2, so 2 times 112. That definitely doesn't add to 60. Let's say 4. Okay. Oh, 4 and 56. All right, well, that was easy. 4 and 56. 4 plus 56 makes positive 60. Now, obviously, I wanted to add to negative 60. Well, if I want to use 4 and 56, I needed to multiply to 224. So if I want to make it positive 224, another option could be negative 4 times negative 56, right? Those two numbers are both negative, so when they multiply, they become positive 224, and when I add them, they become negative 60. So that's going to be the one that I want to choose here. And again, this list could go very, very long, so you just try until you can find those numbers. So negative 4 and then negative 56. All right, so here we go. Let's go ahead and rewrite our trinomial here into 4 terms. So remember that first term stays exactly the same, and that last term stays exactly the same. It's just that middle term is going to be uncombined. So we're going to have negative 4m and negative 56m. Remember, the order of those two terms do not matter, so if you want to put negative 56m first, you may do so. Okay, also, if you do put the 56 first, I'll go ahead and show you how your answer is different, just in case you forgot. Okay, we're going to go ahead and factor by grouping since we have 4 terms now. So in the first group here, the largest thing that I can take out of both would be just a single m. No numbers because there are no common factors in 7 and 4 other than 1. So m is going to go on the outside. 7m squared divided by m is going to be 7m. You have 1 m left over. And then negative 4m divided by m is going to be negative 4, and those m's cancel each other out. Okay, our next two terms are negative 56m and 32. We want a number that goes into both. So let's see, 56 divided by 2, that works. 32 divided by 2. All right, so 2 goes into both of those. Let's keep trying because we want to make sure we try every possible number because we want it to be the greatest number possible. We can try 4. 56 divided by 4, that goes in evenly, and 32 divided by 4. That also goes in evenly. So you keep going. Okay, think about all the numbers that go into 32, right? So you have 1 and 32, 2 and 16, 4 and 8. I think that might be it. I think that's it. Those 6. Okay, so we got to check all of those numbers to see if 56 goes in anything. So obviously 56 divided by 32 doesn't work. Let's try 56 divided by 16. Doesn't work. 56 divided by 8. Okay, so they both have 8 in common, so that means the largest number that can go into both is going to be 8 here. But because that first term is a negative, you want to make sure you take out a negative sign. Okay, so it's negative 8. Remember, the first term in your group is negative, you must factor out a negative. Negative 58, or negative 56 divided by negative 8 is going to be positive 7, and then m stays because nothing happened, we didn't take it out. And then positive 32 divided by negative 8 is going to be negative 4. Parentheses match, so we are good to go, and we keep going. So go ahead and write our first factor. That's going to be m minus 8. And then our second factor here is going to be 7m minus 4. Now, if you were to flip the 56m and the negative 4m around, your answer would be exactly the same, except you just have them be flipped, so it would just look like this. Again, not a big deal. Remember, the order you multiply doesn't matter, so that's also okay. All right, now again, we're not asked to only factor. We are asked to divide the polynomials out. So we actually have to divide here. Remember, this right here, our answer, is the same exact thing as the numerator of this fraction. So I'm going to go ahead and write it out and replace it. So we have m minus 8 in the numerator, and then with the 7m minus 4 in the numerator. So m minus 8 times 7m minus 4 in the numerator, divided by m minus 8. Now remember, this step is called the reduced step. So you're going to cancel out what they have in common. M minus 8 is what they have in common. Whoops. So it's going to simplify to 7m minus 4. No, you don't have to write the parentheses anymore because it's all by itself, so you're all good to go there. All right, and again, you could check this if you wanted. If you were to multiply both of these out, you should get out this guy here. All right, last one is a word problem, but again, with word problems, you just kind of figure out, what do they want me to do here? And once you figure out that, then you can kind of know the math process from there. Setting up a word problem is always the most challenging part. Timmy has a rectangular garden with an area of 3x squared plus 5x minus 12 and a width of x plus 3. Find the length of the garden. Okay, so they told us the area. The area is 3x squared plus 5x minus 12. So go ahead and highlight that bit of information. So area, right, they told us that. I need a bigger highlighter, honestly. They also told us the width is x plus 3. Okay, they want us to find the length. So that's what they want us to find here. Find the length. So length, we have no idea. Well, I do know something. How do I find the area of a rectangle? Well, the area of a rectangle is length times width, right? A equals LW, length times width. Well, they want us to find the length. They want us to get L by itself. So how do I find the length? Well, to get L by itself, how would I get rid of that W? I would divide W out from both sides. So I have A over W equals L. That's the formula we want to use here. So let's go ahead and plug in what we know. A stands for area. Well, we know the area. That's going to go in the top part of our fraction here. So 3x squared plus 5x minus 12 divided by the width. The width we do know as well. That's going to be x plus 3. And we want to find that length. So they basically want us to divide out polynomials here. Take your trinomial, divide it out by x plus 3 to find the missing expression, right? So they're basically giving you one expression. They're giving you x plus 3. They want you to find the other expression. So let's go ahead and find that. Okay, so let's factor that numerator part up. Okay, let's go ahead and factor. So we have 3x squared plus 5x minus 12. Let's do AC method over here. First thing you do is check for standard form and check for a GCF. It is in standard form, and there is no greatest common factor other than 1. All right, so we're going to write our A out. So A is 3, our B is 5, and C is negative 12. Okay, so let's go ahead and write our X. Okay, so A times C here is going to be negative 36, and our B is positive 5. So we need to list out factors of negative 36 and see which one of those adds up to 5. So we have negative 1 times 36. That makes negative 36, but doesn't add up to 5. And then 1 and negative 36 don't either. We have negative 2 and 18. We have 2 and negative 18. Neither of those make 5, so let's keep going. 3 and 12. Negative 3 times positive 12 don't add up to make 5. Or 3 times negative 12 still doesn't add up to make 5, so you keep going. We have negative 4 and positive 9. That one makes 5, so let's go ahead and use that one. We also have 4 times negative 9. I'm going to go ahead and list out the rest because there's not very many left. We have negative 6 times negative 6. Negative 6 and positive 6. Those are our last two. All right, now out of all these combinations, only one adds up to 5, and it's going to, whoa, I forgot that I changed the highlighter size. It's only this guy, so that's the only one that adds up to positive 5. I'll go ahead and flip the order just to show you it doesn't matter. So we'll do 9 and negative 4 instead of negative 4 and 9. Again, order doesn't matter there. So let's go ahead and write our new expression out. So 3x squared and negative 12 stay the same. We have positive 9x and negative 4x in the inside here. We're basically undoing our like terms. We are splitting those up. Okay, so keep saying so. Break it up into groups. You're going to find the GCF of the first two terms. That's going to be 3x. Okay, x plus 3 is our remainder inside there. And then we'll go ahead and find the GCF of the next two. The largest thing that can go into both is 4. But because that first term is negative, you want to make sure you take out a negative 4. So we have negative 4, and then on the inside, we have negative 4x divided by negative 4 is positive 1x. Negative 12 divided by negative 4 is positive 3. Parentheses match, so we are good to go to continue. 3x and negative 4 combine to make the first factor. And then your second factor is made up of one of the matching sets, so x plus 3. Okay, now again, we're not stopping here. We're not asked to factor, we're asked to find the missing dimension. So again, this is equivalent to this guy up here. Okay, we just factored him. So let's go ahead and replace that in our fraction. We have 3x plus 4, and then, oh sorry, it's minus 4. And then x plus 3, is that what it says? Yeah, 3x minus 4 and x plus 3. That's all over x plus 3 from earlier, right? Okay, so we're basically just making it equivalent, and that this is going to give us our length. Okay, you cancel out the one that they have in common, so x plus 3 is what they have in common, so that means that our length must be 3x minus 4. Oops. So that is it for for dividing polynomials. It's basically the same thing as factoring, we just have that extra step of reducing that fraction at the very end. If you have any questions, as always, please feel free to come and ask me for help.